welcome back to my channel CAD by Nagendra. So from this tutorial we are going to start sheet metal design in SolidWorks. Now let me enter into sheet metal design and let me start with options first. So just we'll go here with this new part. Let's say OK. So in SolidWorks, advantage is everything like sheet metal design, surface design, sketcher, everything will be available in a part design only. So no need to go for separate option as like in CATIA. So now here you can see this we call it as tabs. So in tabs we are having here sheet metal. So in your system, if this sheet metal option is not visible, so how to restore that? To show that, just on this any tab you can use mouse right click. You can get one option here, tabs. So here we need to turn on whatever the option we want here. So if you want sheet metal design, we need to turn on. If we don't want, we can turn off. Here sheet metal is not there. Again mouse right click, tabs. We need here sheet metal like this. So just I'll click on sheet metal design. Now under sheet metal design, first option we are having here base flange. So what is meant by this base flange? You can see there preview is available. Creates a sheet metal part or adds material to an existing sheet metal part. A base flange is the first feature in a new sheet metal part. So it is nothing but, so if we are having any 2D profile, by using this base flange, we are going to add thickness to the 2D sketch to convert into 3D. So let me show you how to use that. For example, on the top plane, we'll go for sketch. So just I'll create one rectangle like this, then exit sketch. Now just I'll use here base flange. Why? Because here we are having only 2D profile. This 2D profile we need to convert into 3D sheet metal base. So there we can directly click on base flange. Then here we need to provide sheet metal thickness. What is the sheet metal thickness we need to create this particular part? Let's say for example 2 mm thickness I'll take. Then this 2 mm thickness should be applied with reference to 2D sketch in downside direction or upward direction. Now sketch is here, 2 mm thickness material is adding towards downside direction. If we want reverse, we can make it reverse direction. Now 2D sketcher is at bottom, material is adding towards upside. Or else we can use symmetric also. So symmetric in the sense sketcher will be exactly in the center. So total 2 mm, right? 1 mm thickness will be adding on upside direction, 1 mm will be adding downside direction. So just I'll keep it normal like this. Then bend allowance will be there. So in basic class we have discussed what is meant by this bend allowance, then what is meant by this K factor. So this K factor value should be always between 0.25 to 0.5, that is a standard size. Again formula and all already we have discussed in our basic sheet metal design tutorial. If you have missed it, please watch it. Then along with K factor, we can create sheet metal part by using bend table or bend allowance or bend reduction or bend calculation. So maximum conditions we will use K factor. So I am just going with K factor value. Then auto relief will be there. Different types will be there. About this I'll explain you in one more option. So just I will say okay. So like this. So just if I want to make isometric view, here option is not available. So to restore that, we can go here with this customize commands. We need that isometric related to view. So directly we can go for view. So this is the isometric view option we need to search where it is available. So in this view, different options will be available like this. Or else you can search isometric. So under features not available. So let me check where it is available here. Exploded sketches. So whatever the tools we need to add, so directly from here we can add. So standard views. So here we want isometric. Just you can drag and drop like this. Just I'll close it. So isometric. So that is about this base flange. So next we are having here convert to sheet metal. So what is meant by this convert to sheet metal means we can convert part design file into sheet metal design. So now let me show you how to use that. So just I will delete this. I don't want base flange. For example, on the top line already we are having sketch. So this rectangle I am not using sheet metal. I am using features part design. So just we'll create one block like this. Now this is not a sheet metal part. This is part design, right? So this part design we need to convert into sheet metal. So in such case, in very rare cases we use this. In such case, we can use this option called convert to sheet metal. Just click on convert to sheet metal. Then we need to select here base. So for with reference to which face we need to create that entire sheet metal part. So this base I'll select as this bottom face. Then what is the thickness we want? So I'll keep it as it is 2 mm. Same here, reverse thickness upside or downside we want. Then bend radius I'll keep it 2 mm. Then bend edges we need to select. This is a fixed face. With reference to that fixed face, what are the bends we want? So that bend edges, we need all these four. So just I'll select all these four edges like this. Then just I'll say okay. Now you can see part design is converted into sheet metal design. Like this, we can use this option called convert to sheet metal. We can convert part design to sheet metal design. Then next we are having here lofted bend. So lofted bend is nothing but in part design we have used here lofted boss. Same similar to that. Lofted bend is nothing but when we are having two different sketches at different heights. So in such case, if you want to add material between the two different sketches which are at different heights with sheet metal thickness, there we can use lofted bend option. So let me show you how to use that. Just I will close it. Then I'll go for new part. So on the top plane, for example, we are having one rectangle here. Here one thing you need to remember that already we know sheet metal is nothing but it is made up of only a single sheet. That single sheet will be converted into different type of bendings and we can bend in which way or in which shape we wanted. So here, for example, if you want to create a closed profile like a cylinder shape in sheet metal design by using a single sheet, so directly we can't take round sheet and directly we can't make it. So what we will take? We'll take one flat sheet. That flat sheet in which shape we want, we will bend it. At somewhere we will do any welding operation or clinching operation, any one extra operation we are going to perform to join or to merge these two sheets. So this joining part is there, right? Their opening line should be there. So to provide that opening line, so this profile should not be a closed profile, it should be an open profile. So just to make it open profile, I'll create like this. So this gap little it should be, but it should not be a closed profile. So like this, one profile is there. Then we need one more sketch at a different height. So to create at a different height, we need here proper reference plane. So with reference to this top plane, by using reference geometry plane, I'll create one plane with some height of 100 like this. Then on this plane, we'll go for sketch. Let's say, for example, we are having one more rectangle here like this. Same here also profile should be open profile. So just I'll create one circle. I will trim this. If it is a closed profile, it won't come. It will come under part design. Again, we can make it by using lofted bend part design. Again, by using sheet metal, convert to sheet metal design we can do. But instead of that, direct option we are having here in sheet metal itself, lofted bend. Now, profiles. So first profile I'll select this. Second profile I'll select this. Very simple option. Directly material will be added like this. Then here bend radius, how much we want, we can change it. So what is the distance, like thickness we want? For example, I want here 3 mm thickness, sheet metal 3 mm thickness. Then with reference to sketch, material should be inside or outside or symmetric, both sides with equal distance. Then bend radius, how much we want, we are able to change like this. Just I'll say. So by using this lofted bend, we are able to add sheet metal material between two different profiles which are at different heights. So that is the use of this lofted bend. So I hope you have understood about these three options. So in next video, we are going to continue with these remaining options. So if you feel these my tutorial videos are informative and useful, please share to your friends to whom it will be useful. Thanks for watching. Keep supporting.